Now that we have seen how cognitive services work, let's try to apply them to creating some art. Thing we will be doing is called science art. Science art is the direction of art which combines art with technology. And it can be different kind of technology, but in our case we will take artificial intelligence as a part of computer science and use it to produce some artistic content. In our case it would be a so-called cognitive portrait. We will use cognitive services to determine key points in the face and then align photographs in such a way that we have this interesting result of different faces being blended together. That's why it's also called people blending. It is based on two important techniques. One of them is called facial landmark detection. Facial landmarks are coordinates of different interesting points on our face. For example, eyes, parts of the mouth, eyebrows, and so on. And cognitive services, in fact, can detect facial landmarks for us. We provide them photographs and they give back the coordinates. The second thing is mathematics called affine transformation. Affine transformation is a transformation of an image, like movement, zooming in, zooming out, scaling, rotation, and so on, which aligns different points in the image. So we can start with the photograph which is not aligned in any way, like which occupies any place in the picture, and align it to the center of the screen so that eyes occupy predefined locations. So we'll take the series of our photographs, apply cognitive services to get facial landmarks, apply affine transformations to bring the head into exactly the same position, and then merge all those photographs together to produce a cognitive portrait. To do that, we would have to write some code. But luckily, you would not have to write it yourself if you want to get the simplest cognitive portrait which I have shown you, because I have provided you with the existing code which you would need to execute step by step to get the result. We would be using the computer language called Python. Python is the best language to learn. It's also one of the best languages for science art, because Python has a lot of libraries for image manipulation, for mathematical computations, and so on. And also it has a very nice tooling. You would not have to install any Python on your computer, because we would use a system called Azure Notebook. If you want to learn more Python yourself, there are very good online courses to do that, and you would have links to some of them. And I definitely encourage you to learn Python if you don't know it already. So speaking about the tool we will be using, Azure Notebooks. Azure Notebook is a tool which allows you to write Python code directly in your browser. A notebook is a document which consists of cells. There can be text cells which describe what is happening, and there can be cells with the Python code. And to execute this cell, you press the run button, or you click Ctrl-Enter, and the cell is executed and you see the result. And another thing is that Azure Notebooks allow you to start not from scratch, but with some collection of notebooks. And I have made the collection with all the required code for you. So to draw the portrait, you would need one thing. You would need so-called Microsoft account. Microsoft account is an email address which is used to sign in to different Microsoft services. For example, Outlook.com or OneDrive. If you don't have Microsoft account, or if you don't remember the password, the best way would be to register a new email at Outlook.com. And this email would be automatically your Microsoft account. So to start, you would need to go to the URL ak.ms/dgart14, and that's the address of the notebook with all sample code. You go there, you log in with your Microsoft account, you have your own copy of the notebooks, and then you start going. Let's see how it goes. Let's start creating our own cognitive portrait. To do that, we need to go to ak.ms/dgart14, and that's the Azure Notebook, which contains all sample code, and it's available in English and in Russian as well. And to start using it, we need to have our own copy to clone it. And to start, we need to sign in. So the first thing we do, we click sign in and provide our Microsoft account. I will use mine and a password. And after signing in, you see that I have my name here. I can say clone. I want to clone this project and have my own copy of it. So if I want to share it later with my friends, I can say that it's public, but not necessarily. And I need to say that I trust the contents, and then click clone. And after the page reloads, I have my own copy. Now I start by opening makeart.ipnb, and that's the main notebook we will be using. The notebook contains a mixture of cells, and each cell has either text or code. So all the cells here, the text cells, they describe what goes on. I will not read all of them in detail. I'll just briefly go through, but you are welcome to read them more thoroughly. The way Azure notebooks work is that you have code cells. Here I have, for example, code cells which calculates number of seconds in 24 hours. And to execute it, I click Run, and I immediately see the result below. Well, sometimes not very immediately. Let's start with installing the library for accessing cognitive services. This library is available at the library repository, so we need to download it, install it in our notebook. It takes some time. And while the cell is running, you can see that the asterisk, the star, is displayed next to it. And once it's done, it will display the number. Our first cell had number 1, this second cell would have number 2. We need to wait for this first cell to finish executing, which can take a couple of minutes. And we need to proceed only after this first cell finishes. During this execution, you can see some warnings or even some errors, but typically that's not a problem. Just continue on. Next, we import libraries. Importing means that we make those names available to Python to use. And then we will continue with extracting facial landmarks by calling cognitive services automatically to get the data. To do that, we need the special key to use cognitive services. And the easiest way to get the key is to click here to get a trial key for 7 days. Let's click here, and you are taken to the page where you can get the key. Here you see that there is a number of APIs available. You can request keys for different ones, even for speech, for language, and so on. What we need is Face API. So Face API, and we click Get API Key. To get the key, we can either have the 7-day trial, that's the one we will be using now, or if you want to continue experimenting with those portraits for a longer time, you can sign up for free Azure account. A free Azure account would stay with you forever, but you would need initially to provide more details about yourself, like names, phone number, and even credit cards if you are not a student. So in our case, we'll start with 7 days. So you need to say that you agree, provide country, and then sign in. We will sign in with a Microsoft account for simplicity. I need to provide the data, the same data as I did before. And once I do that, you see that I have the key and endpoint. In fact, I have 2 keys, but I can take any of them. And I need to provide those keys to my notebook to use. So let me copy the first key. I select it, I click Ctrl+C, then go to my notebook and paste it in the code cell here. Make sure to leave the quotes so that it looks like this. Then I need to do the same with endpoint. Endpoint is the kind of address which we use to call the service, and it can differ. So for example, here it's in US, but there are also endpoints in Europe and in other countries. So in my case, I copy this endpoint here. And the only thing I need to do is to remove this trailing face. I just need to leave the address of the server. That's an important thing. If you don't do that, nothing will work. I execute this cell, and now let's test how this service works. I have this sample photograph, and I call the service to get the facial landmarks from this photograph. And I should get this data. You see that it has the number of points, like nose tip and coordinates. If you don't have this kind of data here, it means that something went wrong. You need to go back and repeat steps and find out what you did wrongly. because if it doesn't work now, you would not be able to draw the portrait. The actual code to determine those landmarks was very simple. It's just one line of Python code, detect with URL. And I provide the address, the URL of the image in the internet, and information I want to get. So in this case, I want to return face landmarks. I can also ask to return some more information. For example, I can say here to return face attributes, return face attributes equals to age. In which case, so I need to provide a list here. In which case, in addition to this information, I will also get face attributes, age attributes. You see that the age is 39. So you can get from Face API a lot of different information, but in our case, we need facial landmarks. Now it's time to upload our own images to experiment with. We need to go back to the screen where we cloned our notebooks, and you see that there is a directory called images. Let's click on it. We go inside the directory, and there are two pictures provided here for your convenience. You can delete them by selecting them and clicking delete, or you can leave them here just if you want to include them into your portrait as well. To upload pictures, we click this arrow button and say that I want to upload pictures from my computer. And now I can either choose files and locate the directory on my computer with pictures, or I can open my pictures in Explorer or Finder, select them, and do the drag and drop. It works either way. After the drag and drop, we'll see the list of files here in this window. You need to indicate that you trust the contents of those files, because you know that there are your pictures, and click upload. After all pictures have been uploaded, just click done and return to the tab with the notebook. In case you forget something, here is the instruction provided with pictures how to do that. And once you do that, let's make sure those images are accessible by Python. So I will take the first file and try to analyze it using Face API. Here is my picture, and you can see that facial landmarks plotted just over my face. You see how eyes and eyebrows and lips and everything was detected. And to detect that, we used one method called detect with stream, because we are sending the picture to the cloud, to the service, and getting the result back. Let's do the same with all pictures in our collection. We execute this cell, and this cell will take some time to execute, because all pictures that I have provided are now sent to the cloud, and we are getting back the facial landmarks. And we store all the data in variables called images and image points. If you see error here, because here some errors could happen during processing. For example, Face API is not able to determine a face, or if a picture is too big, because there is a limit to the pictures that Face API can process. Too large pictures, they cannot be correctly processed. So if you see errors, it means that those pictures should either be made smaller, or they are just ignored. It's not a problem, because those pictures are just not processed, but it's important that you have something like 5 or 6 pictures which ended up recognized correctly. You see that in most of the pictures that I uploaded, there is only one face. That's because I selected a good quality picture where the face was the most important thing, and there were no other people. If there is more than one face, that's not a huge problem, but our code is made in such a way that it takes any face from the picture, like the first face that was recognized. And if there are several people, it could happen that not your face is taken, but somebody else's. So that's why it's probably better to upload only big photographs of yourself if you want your own portrait. If you want just a portrait of random people, you can upload any pictures which contain faces. So before going further, make sure that this cell finishes execution, and then proceed to the next one. Let's show some images that we have processed. This function display images is used to display a number of images, and I take 5 pictures from my collection to show them. Here they are. If your pictures are rather big, this can also take some time to execute. Now it's time to apply some mathematics. Affine transformation is the transformation that moves the head of the person to the right position in the picture. We are using the powerful library called OpenCV for image processing, and what you need to do, we need to specify 3 points which can move to 3 other points. In our case, we will move eyes to the predefined positions here, and we will also move the middle of the mouth. To calculate middle of the mouth, we take the left and right points in the mouth and calculate the average, and then getAffine transform gets the transformation and applies it, warpAffine applies it to our image. And we are getting the image of the specified size, in which case 300 pixels. If you want high resolution to put the picture on your wall, you need to adjust the coordinates here. And now let's apply this transformation to all images in our collection, and again see the results for the first 5 images. Here they are. You see all the heads are aligned, and all heads are in exactly middle of the picture. What we are left with is just to mix all those pictures together. Let's see how first 2 pictures mix. You see there is something interesting about this picture, because I mixed 2 different people and I see something in between, which is nice, but not very nice, because still, I mean, if you just take 2 pictures, it's not very smooth. Let's mix all pictures together and see the result. That would be the combined portrait of everyone in our collection. Because I had mostly my daughter, you can see her portrait here, which looks pretty good. How can you improve this? The good thing about computers is that you can add some randomness. In our case, I can specify different weights to different pictures to see different results. The next piece of code tries different merge functions with different weights and displays 5 results, so that we can select the best one. They still look pretty similar, but you see that in some cases, for example, the picture with the hat got more weight, and it looks a little bit nicer because it looks like a person is wearing a hat. And you can select the one that you like. And probably you would want to save the result so that you can share it on social network, or you can put it on the wall or share it with your friends. To do that, let's execute the next cell. Next cell produces another random picture. So this random picture actually looks a little bit like me, so I want to keep it. If you want to get another picture, you just run the cell once more. Actually, let me do that. I run the cell once more and I get slightly different result and slightly different result again. And once you are happy with the result, you execute the next cell to save it to disk. You see, it writes the result to the file called result.jpg. To find this file, we go back to the tab with our project, the tab where we have cloned the notebooks. We need to go 1 directory up, and here it is, the result.jpg. You can click and see the file here, and you can download it to your computer. So I have shown you the basic techniques for drawing cognitive portrait, but this is only the beginning. Because what we do, we simply mix images together, aligning their eyes. But we can do much more than that. For example, you can find some nice way to align eyes on one line, or you can display photographs side by side, or even in circle. And all those different techniques would produce different artistic results. So here we use the code as a good tool, as a good instrument to express our creativity. And we can think of many more ways to do it. So I encourage you to learn Python to produce more portraits like that. And if you do, please share the results, share them on social network, or I would be glad if you send it to me, because I always like to see how people can use technology to express their creativity. So lots of luck with experimentation and with learning programming and doing more and more cognitive portraits.